Hello and welcome to Rocket Lab's 43rd Electron launch, a dedicated mission for Spire and Northstar called Four of a Kind. It's our first launch of the new year from Rocket Lab Launch Complex 1 in Mahia, New Zealand, and on your screen right now is a live view of our Electron rocket for today's mission. My name is Muriel Baker. Thank you for joining us for this next Electron launch.
And I'm Prachi Saknani. It is so great to be back and straight into launching the first Electron of our sold-out 2024 launch manifest. We have a red booster on the launch pad at LC1, which means today's mission is also a recovery mission. We have a live view here from the camera on board our recovery boat stationed out in the Pacific Ocean, waiting for the mission to lift off before the rocket's first stage returns to the ocean underneath a parachute. Launch and recovery ops are so far on track for our scheduled liftoff time at 7:22 p.m. local, 6:22 a.m. UTC, and if you're in the U.S., that means 1:22 a.m. EST or 10:22 p.m. PST.
Great memory there, Prachi. Today's primary mission is to deliver 4 satellites to low Earth orbit. Now, these space situational awareness satellites will be operated by Spire for Northstar Earth and Space, a company that monitors space traffic and debris to enable safe navigation in Earth orbit. They detect and track objects in space to issue proximity alerts and help other space users maneuver and avoid collisions. For more about their mission, here is Northstar Earth and Space.
What's unique about Northstar is that we see all orbits at the same time. All other systems have limitations in terms of what they can see. They either see low Earth orbit, or they see something fixed in space, or they're staring at something in space, but our system sees all of it. We used people with expertise in orbit mechanics, orbit dynamics, flight navigation and control, mathematics, software development, etc. To say, well, how can we do this? No one's ever done it before. You start with the fundamental problem on the algorithm side of turning a streak of light that goes quickly across a camera screen out of focus and turn it into an accurate ephemeris, which is the prediction of an object flying across the sky, where it's going to be in 24, 48, 72 hours. We're taking 2D images and converting it into a 3D map of space. Knowing accurately within meters where objects are in space instead of kilometers is the game changer. It's about having precision and not guessing. The world's economy depends on space. We've already come a long way along this new space economy. There's constellations up there, there's constellations coming fast that we need to get out in front of. These constellations are building the future, and Northstar's making sure there is one.
Today's payload consists of Spire's 4 Lemur satellites, which are headed to a 530-kilometer sun-synchronous orbit at a 97-degree inclination. Each of the 4 lemurs, which stands for Low Earth Multi-Use Receiver, will form part of Spire's already existing constellation of nanosatellites in LEO.
They'll be launched today from LC1 Pad B, our second launch pad at Launch Complex 1. We've conducted most of our Electron launches from LC1 over the years, and both Pads A and B are expecting a busy year of back-to-back launches, along with missions scheduled from our Launch Complex 2 in Virginia throughout 2024.
The Electron rocket carrying today's Spire payloads is a 3-stage liquid-fueled launch vehicle designed specifically for small satellite missions needing a dedicated ride to space. Electron is made from carbon composite, a strong but lightweight structural material that gives our rocket its unique black look. Electron is white on the outside, though, because of the super cold LOX that runs through its propellant tanks, which causes moisture to condense as ice on the rocket. And for recovery missions like today's, particularly on Electron's first stage, the rocket actually looks silver. And that's because the first stage is covered in a silvery TPS, or thermal protection system material, which helps Electron's first stage survive its return to Earth after launch.
There are 10 Rutherford engines across the rocket, 9 at the bottom of the first stage, and a 10th engine with a larger nozzle designed for space on the second stage. All 10 of these Rutherfords are 3D printed and electrically powered by batteries, which makes them pretty unique as far as rocket engines go. With a 3D printed combustion chamber, injectors, pumps, and main propellant valves, Rutherford was the world's first 3D printed orbital rocket engine. Instead of being powered by traditional gas turbine pumps, Rutherford uses a cycle of brushless DC electric motors and high-performance lithium polymer batteries to drive its propellant pumps. This cuts down on much of the complex turbo machinery typically required for gas generator cycle engines, meaning that the Rutherford is simpler to build than a traditional engine, but can still achieve 90% efficiency. They use a mix of liquid oxygen and kerosene to generate 224 kilonewtons of thrust at liftoff, while the second stage's Rutherford engine is capable of about 25.8 kilonewtons of thrust.
And that's not all. There's actually an 11th engine on Electron called the Curie engine, which sits on top of our second stage and powers the kick stage. In the simplest form, the kick stage serves as in-space propulsion to deploy the satellites attached to it to orbit. It gets the satellites precisely where they need to go, whether it's across multiple trajectory changes on a rideshare mission or to a very specific or difficult to reach point in space that can only be achieved on a dedicated ride. The brilliant thing about the kick stage's ability to relight its engine is that it can then send itself on a deorbit path once the mission's done, helping to minimize space junk in orbit.
Now, when it comes to recovery missions, there are additions to Electron that we should point out as well. Attached inside the first stage, where that red band is below the second stage, are 2 sets of parachutes to help Electron return to Earth for recovery. When the first and the second stage split apart, while the second stage continues the mission to orbit, the separated first stage makes its way back to Earth. It maintains its trajectory on an arc, keeping that red end facing upward so that the heavier end of the first stage, where the engines are, leads the way back home. Now, once Electron is back through Earth's atmosphere, the first drogue chute will be deployed from the first stage to help slow it down. Then we'll have the release of the second main parachute, also attached internally to that first stage, which really decelerates the speed of the first stage ahead of it landing softly in the ocean for collection by our recovery vessel and our ocean crew. Bringing you a quick update from Mission Control here. The launch director has adjusted today's T0 time to allow just a little bit of extra time for sensor data to come up to temperature. The new T0 time is now 0634 UTC, approximately 30 minutes from now. We have 28 minutes left on the clock as our team works towards that new target time of 1934 local time for liftoff. Meanwhile, our recovery operators are also ready and waiting for today's launch and their latest attempt at bringing Electron back to Earth from space after liftoff. You can see the live feed from the camera on board our recovery vessel on your left-hand side there. This is all part of our plan to make Electron the world's first reusable orbital small rocket. Because if we can reuse our rockets instead of building brand new ones every time, then reusable rockets will help bring down the cost of space access and open up even more launch opportunities for satellite operators on Electron. First, of course, we need to bring back Electron's first stage from space after liftoff. So here's more on how we plan to do that.
Electron is one of the world's most innovative rockets. Since its first launch in 2017, it's pushed the boundaries with 3D printed engines, electric turbopumps, and new carbon composite technology to become one of the most reliable and frequently launched rockets every year. And what's faster than building more rockets? Reusing the ones you already have. Which is why we're evolving Electron into the world's first reusable small orbital rocket, so we can launch, splash down, and launch again. Here's how we'll do it. First, Electron lifts off from the pad with 9 Rutherford engines on Electron's first stage propelling the rocket toward space. Around 2.5 minutes after liftoff, at around 70 kilometers above Earth, the 9 Rutherford engines on Electron's first stage shut down, allowing the rocket's first and second stages to separate. Tiny reaction control thrusters reorient the stage to the correct angle of attack to slice through Earth's dense atmosphere as it descends. The 12-meter-long stage falls to Earth at top speeds of more than 8,000 kilometers per hour and a temperature peak of close to 2,400 degrees Celsius. About 5 minutes after stage separation, as the stage returns to Earth, a drogue parachute is released at around 13 kilometers altitude to help slow the rocket down. Less than a minute later, the larger main parachute is deployed from the first stage, bringing Electron's speed down from thousands of kilometers an hour to less than 40 kilometers an hour. Meanwhile, our recovery vessel waits patiently outside the splashdown zone in the ocean, several hundred kilometers from the launch site, and awaits confirmation of splashdown by telemetry. Once the captain receives confirmation, the chase is on. The recovery team speeds to the booster's location at sea, typically rendezvousing with it just minutes after splashdown. Using a specially designed marine retrieval apparatus, Electron's first stage is plucked from the ocean and secured on the vessel for the return trip home to our production complex to undergo testing and refurbishment for reflight.
The success of today's recovery attempt will, of course, determine our next steps towards the ultimate goal, which is to refurbish and refly an entire Electron first stage on a future flight.
Now, while the videos didn't mention it, we have reflown some pretty significant hardware on our most recent recovery missions, including a Stage 1 Rutherford engine. The engine first launched on our 26th Electron mission called There and Back Again in May of 2022. After it was brought back from the ocean to our factory, the engine went through testing and qualification hot fires to make sure that it was ready to launch again. We then added it to the power pack of our 40th mission called We Love the Nightlife, where it performed as well as any newly built Rutherford engine that we've launched before. Its performance for that mission was validation that some of our most crucial hardware can be launched again and again, and so we can't wait to see how the team builds on today's recovery mission to get us closer to relaunching an Electron first stage in its entirety.
If you're just tuning into the live stream now, I just want to share a quick update that we've had a bit of a push to the right with the launch target time for today's mission. We're now targeting 1934 New Zealand local time or 0634 UTC.
Now, watching a rocket launch is a spectacular experience no matter what, but it's particularly special if you had a hand in building and launching it yourself. And as luck would have it, you might have an opportunity to do just that. We're hiring across our Electron team right now, and the kind of experience we're looking for might surprise you.
As it was sitting on the pad, just messaging on the phone, like, is it gonna go, is it gonna go? My heart was pounding. And then it took off, and it was probably the most proud I've ever been of myself. It was a really cool moment.
I thought when they were looking for technicians that worked in aircraft, that had an attention to detail they were looking for, I thought I align well with that. I'd love to be in the space industry. I thought I'd give it a shot. The worst that happens is to say no, and here I am.
I was in school. I never considered working at a rocket company, building rockets. I mean, working for a rocket company is kind of a big deal. However, like I said, I came from school and I was able to learn on the job as an apprentice, so there's always that option. But however, none of us were building rockets before this, no one around here really. So we've all been learning and growing together as a team. So anyone can be like us.
I like to think of myself as like an electrician still, but like a space electrician. So that's kind of how I describe it. It still takes people minutes to realize what we do. So yeah, it's funny just seeing the cogs tick and then realize, yeah, we're not just making something up, basically.
So I would say a drive for continuous self-improvement is a big one. You know, we're always trying to improve the product and improve time and quality and everything like that.
I came into Rocket Lab not having any experience. I had no preconceived ideas of what I was going to do. And I've been here 6.5 years now. It's been a hell of a ride. I've loved every minute. There's been a lot of challenges, but every one of those challenges, I get to look back on and be like, it's been the best time of my life. Building not just Electron, but building things that have been to the moon, things that are going to Mars, things that are hopefully one day going to go to Venus. And for that, I'm extremely grateful and proud of what I get to do here.
I've sort of learnt more about being a leader, more about working with people and how to make certain people work well with other people, for example, and a lot of people need different things. The advice I give to someone who wants to work at Rocket Lab would probably just be
Apply yesterday.
yeah, whatever you want to do, there's something here for you. As long as you've got the right attitude, there's a pretty good chance you'll be able to work here.
It's worth it, right? Like all of the hard work that you put in, this is the reward for it. And it's crazy that we have people who are so smart and so young doing amazing things. I never ever thought that I would be here. And look, here I am building power packs. As it was sitting on the pad, just messaging on the phone, like.
We're at T-minus 14 minutes, 25 seconds and counting to lift off for our 43rd Electron launch and our very first mission for 2024. Now, the weather hasn't exactly played ball with us this week, but we are happy to report conditions are much better today. And the weather team has given us the green light for both LC1 and out at the recovery zone for weather. Coming up to 13 minutes to lift off, and things are looking good for an on-time launch. The range is clear and ready to support. Electron and its payload are both healthy, and the weather is behaving nicely so far. Now, coming up very soon will be the go, no-go poll run by our launch director, Joseph Carpico, from Mission Control here in Auckland, to determine whether to proceed with that countdown to launch. So let's listen into the comms channels for that update.
All operators, this is the LD on mission, proceeding with the go, no-go sequence. Stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Beacon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
RF.
RF is go.
MM.
MM is go.
Recovery.
Recovery is go.
LD sub.
LD sub is go.
That concludes the go, no-go sequence. We are T-minus 11 minutes, 20 seconds and counting. We are go for terminal count at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
That was Launch Director Joseph Carpico at the end of that go, no-go poll, confirming that the team is happy to move forward to liftoff. I want to give a special shout out to Mr. Carpico today as well, because this mission will be his 100th launch, which is just an incredible career milestone. He joined Rocket Lab with over 50 launches under his belt from his time in the US Air Force and the then Hughes Space and Communications Company, as well as launches with the Sea Launch Program and the Antares Launch Program. His contribution to our Electron launches since 2019 brings his launch tally up to 100 today, and we couldn't be prouder of Joe or more thankful for his dedication and service to the space industry. And so it's only right that he is today's launch director and whose voice you will hear behind today's 10-second launch countdown to liftoff.
It's set to be a busy year of Electron launches with a sold-out 2024 launch manifest. But it is also an exciting time in our space systems businesses, where we build satellites and their components for missions that make drugs in space and conduct science experiments on Mars. With more Rocket Lab spacecraft in build and backlog than ever before, this year is also set to be a mammoth year for our space systems teams across the world. Let's take a look at what they're getting up to across our facilities. We're building satellites at scale. We might have started with rockets, but today, Rocket Lab is a major space prime. We're designing, manufacturing, and operating satellites for government and commercial customers. It all starts with mission design. We partner with our customers to develop tailored spacecraft solutions. Starting with reliable, flight-proven spacecraft platforms, we tailor each spacecraft to each individual mission's requirements. Whether it's a science mission to study our solar system's planets, a technology demonstration in low Earth orbit, or a constellation enabling communications or national security, we are building satellites that make it possible. They're manufactured at our spacecraft production facilities, home to a 12,000 square foot state-of-the-art clean room and more than 40,000 square feet of streamlined production and test facilities designed to support constellation-class manufacturing and satellite assembly, integration, and test. We've been intentional in developing a vertically integrated supply chain for our satellites, manufacturing components, subsystems, and software in-house to drive efficiency, accelerate production timelines, and deliver cost savings. This means Rocket Lab spacecraft incorporate flight-proven star trackers, propulsion, reaction wheels, solar cells, panels, and arrays, flight and ground software, radios, avionics, composite structures and tanks, and separation systems. And our customers know they can rely on these since Rocket Lab components and subsystems have flown successfully on 1,700 missions globally and counting. Following final assembly, integration, and test, we ship the completed satellites to the launch site for integration to the launch vehicle, whether that's Electron, Neutron, or an entirely different rocket. Once launched, we have global ground station coverage, enabling our customers to communicate, downlink, and process data from their satellites thanks to our satellite operation centers in Long Beach, California, Auckland, New Zealand, and Littleton, Colorado. With more than 40 Rocket Lab satellites in development across our factories right now, there's more than just rockets in this lab. On top of this, just a few weeks ago, we announced our biggest space systems contract ever, a $500 million agreement with the Space Development Agency to design and build 18 satellites for their LEO constellation known as the Transport Layer. This constellation provides assured, resilient, and low-latency military data and global connectivity to meet the DoD's needs. Work has already begun on building these 18 satellites, which are made up of subsystems and components we produce in-house, just like you saw. SDA's approach to building out this constellation favors speed, schedule certainty, and affordability. We've proven ourselves of this across our launches and other spacecraft programs and are now ready to deliver on this for the SDA.
We are now 6 minutes and 18 seconds and counting to liftoff for tonight's four-of-a-kind mission. Now, tonight's pre-launch operations will follow much of the same process as a standard Electron launch you may have seen before, but with today's launch doubling as a recovery mission, it's after liftoff when you can expect to see changes in the mission profile. 2 minutes before launch, Electron will switch to internal power and enable its onboard launch safety system called the AFTS, or the Autonomous Flight Termination System. This puts safety control in the hands of the rocket's computer, which has a pre-programmed set of safety parameters that Electron must fly within. Anything outside of those bounds, then the AFTS can issue a command to terminate the mission. Now, Mission Control will call out both of these actions across the nets. At under a minute to liftoff, the propellant tanks will be at their optimum pressure levels for launch. Ground control will then confirm the water deluge system on the pad is ready to be activated for when the engines on the rocket ignite for launch. And this is what causes the large white cloud of water vapor that you see at liftoff. Then we get to T-minus 10 seconds and the launch director counting down with the launch clock. Then the engines will ignite at T-minus 3 seconds and the launch pad's hold down mechanisms will be released for Electron to take flight at T0.
Now, from liftoff, Electron's first stage will burn for about 2.5 minutes, propelling the rocket past supersonic speeds and through a launch milestone called Max Q, a critical pressure point during ascent. We then come to MECO, or main engine cutoff, when we switch off those 9 Rutherford engines and separate the booster from the second stage. When the second stage's sole engine lights up to carry on with the mission, it is at this point that our recovery operations begin for Electron's first stage. After an orientation adjustment, the booster will descend back towards Earth, and we can track its progress through the onboard camera for as long as we can, though be warned that the camera may be expected to cut out at some point during that descent.
Now, while all of that is happening, the second stage with Spire and Northstar satellites will be going through their own series of events. The rocket's fairing, or the nose cone, will split and fall away, and we'll also hear Mission Control call out battery hot swap for when the second stage's power system switches to new batteries for the engine's motor controllers. At the end of the second stage's 7 minutes of flight, we'll have another engine cutoff, and then Electron's kick stage, which the satellites are attached to, will separate.
Now, alongside all of that, Electron's first stage will be continuing its journey back to Earth. The first stage is expected to deploy its first parachute at about 7 minutes after liftoff. While we might not see that happen on screen, we should still hear the call out from our operators and mission control. This will help reduce the stage to subsonic speeds before the main parachute is deployed at about 8 minutes into the mission. Splashdown will then occur at about 10 minutes after that main chute deploys. Once that's confirmed, our recovery team will move in and get to work to bring Electron up onto the deck of their recovery ship, do their initial assessments, and then strap it in for a secure ride back home to land.
And again, while all of that is happening, our primary mission will continue. It takes about 40 minutes or so after the kick stage has separated for it to complete an elliptical orbit of Earth. We want to deploy the satellites in a circular orbit, so once this elliptical trip is complete, the kick stage's engine will circularize our orbit. That takes only a couple of minutes before the trajectory is set and the satellites are ready for departure. And then it's about 90 seconds or so to deploy all 4 LEMUR payloads because they'll leave their deployers 2 at a time. We'll have an animation of that payload deployment process to talk you through when it happens, so make sure to stick around or join us again after liftoff for those final moments of the mission.
We are now just 2.5 minutes away from liftoff of Electron. We're going to hand it over now to Mission Control to take us through the rest of the countdown, and then Muriel and I will be back with you after liftoff as the mission makes its way through those milestones. Go for of a kind, go Electron, and go Spire and Northstar.
Vehicles on internal power. The FTS is green and able to flight.
Lock system is in recirculation. Anti-geysering has been disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
Flow engine purge is enabled. T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we have liftoff.
Electron has successfully lifted off from Rocket
Stage
Lab
one
Launch
propulsion is
Complex 1 with its Spire and Northstar payload. The rocket is on its way to low Earth orbit with those 4 satellites on board, now T plus 40 seconds into flight. Electron has begun its pitch over, moving up and on an angle to head away from the launch pad and out over the ocean. Now all is looking nominal so far as the rocket approaches max Q, the moment in ascent when Electron experiences the maximum amount of aerodynamic pressure.
Electron is supersonic, approaching max Q. Cleared max Q.
A good call out from Mission Control there that Electron has cleared max Q. The rocket is now 16 kilometers in altitude and moving at over 2,000 kilometers an hour, which you can track the mission's progress by that telemetry dials at the top right-hand corner of your screen.
Next up for Electron is MECO, or main engine cutoff, quickly followed by stage separation and the startup of the Rutherford engine on that second stage to continue the mission to orbit. The 9 engines of the first stage will throttle down and then shut off just before the first and second stages separate from each other. When that happens, the second stage with the Spire satellites will maintain its orbital trajectory and continue on with the mission, while the first stage of Electron will begin its reorientation maneuver to position itself for the return journey to Earth. Now, these 4 events happen in quick succession and are coming up shortly.
15 seconds to staging. Entered burnout detect mode. MECO confirmed.
That's confirmation
Stage
of
2
MECO,
ignition
stage SAP, and Rutherford engine ignition on stage 2. The telemetry dials at the top of your screen continue to show the speed and altitude of the second stage for the primary mission, with the stage 2 nozzle glowing bright above the stunning Earth.
Stage 2 propulsion nominal. Fairing jettison succeeded.
That was the call for fairing jettison on the second stage, which you saw there for yourself. That means Electron's nose cone has successfully split apart and fallen away. And we do this in preparation for deploying the kick stage with its satellites and to get rid of the dead weight of the fairing now that we are through Earth's atmosphere. We have got the trajectory graph showing on your left-hand side and on the right-hand side, which track the stage's current altitude, matching the nominal altitude that we need to reach orbit. On the left-hand side, Electron's stage 1 trajectory is on its way to the highest point of its momentum arc, and once it reaches this apogee, the stage's trajectory line should start to come down as its altitude begins to drop too. You are seeing, though, on your screen that movement of the booster as it redirects to come back to Earth bottom heavy. That way, the engines bear the brunt of the re-entry forces rather than shredding the carbon composite at the top of the stage. The stage will move quickly as it is pulled back to Earth by gravity, and at its peak, the first stage will reach around 8 times the speed of sound and generate so much friction that we could see a red-orange glow from the heat as it descends. It is T plus 4 minutes and 33 seconds into the mission, and Electron's second stage carrying today's payloads remains on course for payload deployment within the hour. Now that second stage is clocking speeds at more than 10,000 kilometers an hour, having now passed 174 kilometers in altitude. For Electron's first stage on its return journey back to Earth, we have had the stage reach its apogee, flip into its atmosphere re-entry position, and begin dropping in altitude as it speeds up on its homeward bound trajectory. It will travel this way for a few minutes before its drogue and main parachutes are deployed to help slow it down.
The end of Stage 2 may look a little different than what you're used to from our previous launches, but this is due to the implementation of BEAST, or our electrical arc suppression system, which ensures all electronics on board can function nominally. In particular, you might notice the addition of a nitrogen tank that maintains pressure within this stage. We're now listening to hear the call from Mission Control for battery hot swap. This hot swap maneuver will allow the continuous energy supply to the Rutherford engine's electric pumps, which deliver fuel to the engine's combustion chamber at extremely high pressure.
Hot swap successful.
A good call from Mission Control. Electron's second stage has completed the battery hot swap. The second stage is maintaining its momentum at more than 15,000 kilometers an hour, now past 200 kilometers in altitude.
And we are currently at T plus 6 minutes, 39 seconds into the mission, and the next critical milestone we are tracking is the deployment of the drogue chute on Electron's first stage. Watch that left-hand side of your screen.
AFDS has saved. Confirm drogue deploy.
As you can see on your screen there, a fantastic view that we have the drogue parachute. It has been deployed from that first stage of Electron. We heard that call from Mission Control as well, so that seems like a nominal drogue chute deploy since we haven't heard anything different from our operators. That means we'll move next to the main parachute deploy, coming up in around 30 seconds, which we should also hopefully see happen from that live camera feed on stage 1.
Main parachute deploy. HVB battery discharge, holding nominal.
Another great call out from Mission Control. The main parachute on Electron's first stage has successfully deployed. This means the booster's pace will have slowed down significantly and should now be drifting gently towards the ocean. It's expected to take around 10 minutes for the booster to reach the water surface, but we'll keep the comms channels up for Mission Control to share updates as they come through.
Entered burnout detect mode. Guidance is in 2 minutes, 26 seconds remaining.
Now back to the primary mission, and we are coming up on the final few seconds of stage 2 engine burn. We will then have second engine cutoff, or SECO, which shuts down the engine ahead of the kick stage separating for its phasing orbit of Earth. And we're listening out for those events now.
SECO confirmed. Stage 3 separation confirmed.
Great news from Mission Control with that second stage engine cold and the kick stage separated. We are now in the final stages of this 4-of-a-kind mission. The kick stage and Spire and North Star satellites are now in a coast phase around Earth. After that elliptical orbit of Earth is complete, then the kick stage's engine will light up to set the stage and the satellites on a circular orbit before payload deployment. The stage's coast phase will last about 40 minutes or so, and then there is payload deployment before we can call mission success for Electron's 43rd launch.
Before we break, though, the latest on recovery is that all is continuing as planned for Electron's first stage and its slow descent to the ocean. Our recovery crew are on standby in the recovery zone, waiting for that splashdown before they can move in and get to work.
Take a bit of a break now on the webcast, but we will come back to you in a few minutes with confirmation of that booster splashdown when we hear it. So we'll leave the audio channels up so we can listen in for that in real time from Mission Control. Otherwise, we will see you back here shortly.
Nominal transfer orbit achieved. Confirms stage 1 splashdown.
Hello again from Rocket Lab Mission Control. As you might have just heard from Mission Control and seen on your screen, Electron's first stage has just successfully splashed down in the ocean after its return journey from space. We're going to bring that up on screen very soon, if we can bring that back from the rocket. But right now, the Electron recovery team are making their way to the stage in the water. They're about 10 minutes or so out. They'll complete safety checks and an initial assessment of the stage's condition before they attempt to bring it on deck of the recovery ship.
As we get updates from the team, we'll bring them to you here live on the webcast. Until then, we'll keep an eye out on the recovery vessel and the primary mission with the animated tracking graphic that shows the position of the current payloads above us, as 4 of a kind make their way to their mark, with payload deployment starting at T plus 50 minutes. We'll see you back here then.
Recovery vessel is inbound, approximately 12 minutes, and they have eyes on the stage in the water. We also have a solid telemetry feed from the stage as well. And a further update on stage 1. Stage 1 altitude is 0 and speed is also 0. and stage 1 is saved. Both tanks are depressurized. Recovery vessel still inbound, approximately 6 minutes. Recovery vessel is switching to retrieval operations preparation. Confirm visual on the stage and that it's floating well.
Curie catalyst heater scheduled to enable.
And this is recovery. We have visual confirmation that the stage is intact and floating happily.
Hello again from Rocket Lab Mission Control. A quick update for those of you still watching. You are being treated to a live view of Electron's first stage bobbing happily in the ocean as the recovery team prepares to bring it on board. We should see that on your screen shortly. Hello again from Rocket Lab Mission Control. As you can see on your screen, Electron has made it to space and back and is now taking a relaxing dip in the ocean. And from here, our recovery team will hoist the stage on board the recovery vessel, ready for the trip back to our production facility. And maybe, just maybe, it might just get a second trip to space.
AOS Spain. AOS Azores.
Hello and welcome back to the webcast for our 43rd Electron mission, 4 of a kind, a dedicated launch for Spire and North Star Earth and Space. We have had a perfect mission so far to deliver today's payloads to a 530-kilometer low Earth orbit and smooth operations for Electron recovery.
Electron cleared the pad at Launch Complex 1 at 19:34 New Zealand local time and soared cleanly through its first launch milestones. That's Max Q, MECO, stage separation and second stage ignition. And shortly after that, the rocket completed a successful battery hot swap for its stage 2 engine before the Rutherford shutdown is planned for kick stage separation.
While all of that was going on, we have, of course, had a secondary mission underway to bring Electron's first stage back to Earth from space. After a clean separation of the first stage after MECO, the booster had a great return journey through Earth's atmosphere with successful operation of its onboard reaction control thrusters to correct the stage's return trajectory. Falling fast, the first stage hit peak speeds of about 8 times the speed of sound and some intensely high temperatures from atmospheric drag.
Having survived that hard and fast journey, we had successful deployment of the first stage's 2 parachutes to help slow Electron down to just 10 meters per second. Electron has since successfully splashed down, and our team are deep in recovery mode to pull that booster out of the water and up on deck. Once it is on board, they'll desalt the vehicle as much as they can to preserve the stage for its trip home to land and to the factory.
Right now, though, we are just seconds away from Curie engine shutdown on Electron's kick stage and the beginning of the payload deployment process. We should be hearing the call for engine shutdown shortly, so let's listen in.
Curie engine cutoff confirmed.
Apogee at 531.2 kilometers, perigee at 529.8 kilometers, and an inclination of 97.490 degrees.
Good comms from Mission Control there. That Curie engine has shut down ahead of payload deployment in the next 30 seconds.
Payload 1 and Payload 2 deployment confirmed.
There we go. The first 2 of 4 Lemur satellites have been deployed from the kick stage. Let's keep a close ear out for the second deployment milestone, sending the last 2 satellites for this mission off to work in Leo.
Payload 3 and Payload 4 deployment confirmed.
That was Mission Control with the good news. We have successfully deployed all 4 of Spire and Northstar satellites to orbit. And with that, we have completed the primary mission for our 43rd Electron launch. A massive thank you and congratulations to our mission partners and to all of Rocket Lab's teams for another mission success.
Out in the ocean, our recovery team are busy securing Electron's booster on the boat for the return journey back to our factory. We'll keep you posted on how that goes, so keep an eye out on our social media pages for more information on our secondary mission. We're going to end the broadcast now, but we are very, very excited for what is coming this year for Electron, Space Systems, and Neutron. The Rocket Lab team around the world are hard at work reaching milestone after milestone, and what a way to kick off 2024 with a successful launch and recovery.
So, for the first of many times this year, thank you for joining us. This is Rocket Lab Mission Control signing off.